In this video, we're going to put our wire harness together. To start, we're going to mount our boards to Dexter. Take your micro SD card with the brain on it and put it into the slot on the bottom of the micro Z board. Then mount your micro Z board onto your motor control board. It should snap on. Take your 4 PCB spacers and put them in the screw holes under the FPGA. Then slide 4 M3 by 20mm bolts into each of the holes. Take your PCB brackets and put them around the tube between the end arm and arm body. Face the open side to the side where you can see the harmonic drives. Align the back of the board assembly with the PCB brackets. Thread your bolts into both PCB brackets and tighten down all the way. Once your FPGA is mounted to your Dexter, take 2 lengths of 24 gauge wire with your power connector and strip the ends. Tin them and then connect them to the power connector with red going to positive and black going to negative. Connect these to the corresponding places on the main power of the PCB. One thing you should do now is identify which wires are coming from the pivot and base. The ones going to the base can move around the center hole of the main pivot freely, while the pivot wires are coming out of the side of that hole and are a bit more restricted. Now we're going to solder our connectors together. This is the board that we use for laying out our wire harnesses with lengths written on them. The lengths for the connectors are as follows. The end arm is 70mm, pivot is 340mm, angle is 400mm, base is 600mm, and rotate is 570mm. The lengths for the optical board diodes are as follows. Base is 70mm, angle is 230mm, rotate is 210mm, end arm is 210mm, and pivot is 200mm. If you purchased a kit, these will be pre-measured and cut for you. The first thing you want to do is tin your 6-pin connectors after crimping the pins flat with a pair of pliers. Just take some solder and coat each of the pins with a layer of solder. Repeat this for the other connectors. Next, we're going to tin the LEDs and phototransistors. There are indentations on the leads, and the middle of that is a good place to cut them. Tin both leads after cutting and repeat for the remaining diodes. Keep them in something like a small bowl so you don't lose them. Then, put one of your 6-pin connectors into the 6-pin holder for soldering wires. 2 are provided in the kit and the STL is on our Thingiverse. Strip one of the 28 gauge black wires in a set and put it at one of the ends of the connector. Solder it to the pin and follow the pattern black, red, blue, white, green, and yellow for the connectors. After you solder them all, give each of the wires a little wiggle to make sure you have a solid connection. Now you're going to put strain relief on the connector. Take one pair of your 6-pin strain relief and line the bottom piece up with the tops of the solder connections. Put some hot glue into the piece to engulf the solder connections and put the top over it. After this, you want to solder the other end on for the end arm and the pivot. Wait until later on the second end for the base, rotate, and angle. Put your connectors onto Dexter even if they're only halfway done. The labels on the motor control board match up with the names given to the connectors. Now we will connect the motors to the motor control board. You may need to extend your motor wires by about 4 inches. The sections for the motors are labeled J1, J2, J3, J4, and J5. The layouts for the wires are labeled with abbreviations for red, black, blue, and green. The base goes to J1 and the pivot goes to the one labeled J3. The external gear goes to the one labeled J2 even though it is J3 in programming, and vice versa with the pivot. The left differential motor from the front of the robot goes to the J4 and the right goes to J5. Take your 6x wires for your base along with your power connector wires and feed them back through the right of the FPGA. You want to keep the wires tidied up along the PCB brackets. Then take your 28cm braid covering and feed your base and pivot motor wires through it. After that, feed your power connector wires and base connector wires through the opposite side. Turn the pivot and make sure that none of the wires are getting yanked on from the main pivot. Make the hole that is made between both main pivot plugs bigger by cutting each side. After that, feed the end of your power connector wires through the side of the main pivot plug that has a hole in the center. Put that half into the hole in the main pivot while keeping the other wires in the half hole. If your braid is frayed, you can trim some of it off. Then plug your Ethernet cable into your FPGA and feed it back through with the other wires. Give it about as much length as you did for your main braid and put it into the center of your main pivot plug with the rest of the wires. Then put the second half in the plug and push it down until both sides are even. Next, you're going to do your wire entry plug. You want the bottom of it to meet with the top of the arm body. Get all of your cables running from the main pivot inside there, including the Ethernet cable. Secure it down with hot glue and push the wires into the plug. Secure the other side down as well. Seal the seams with hot glue. One thing you can do to clean up the look is securing the Ethernet cable to the braid with either cable ties or your excess Kevlar. Connect the base and pivot motor wires to the board. After the main pivot plug has been completed, you're going to attach the fan. Cut a 6-pin connector into a 2-pin piece. Line the inner groove of the fan bracket with super glue and push the fan in label side down with the wires sticking from the top. Then put some super glue in the crack between the two. Then thread 2 M3 by 20mm bolts through both holes on the flat side. Raise your board slightly and unplug your Ethernet cable and align the fan bracket with the two bottom holes below the FPGA. Then tighten two M3 nuts on the back to hold it in place. Plug your Ethernet cable back in through the bottom right corner of the board. Make sure your fan bracket isn't smashing the cable and then slide the board back down. Feed your red and black wire from your differential back down through the shaft and through the end arm hub so that it comes out of the side where the board is. Then trim them down so that it can connect to the 5-volt connector with a fair amount of room to move. Cut the connector off the fan and strip all 4 wires. Solder the matching colors together to make a Y connector and put a piece of heat shrink below each connection. Then solder the pairs onto each of the pins on the 2x. Move the heat shrink down over the connection and heat it with a lighter. The diodes have a flat side, which is where the power lead is. Push them into the LED rig with the flat side on the left. 2 LEDs go on the left and 2 phototransistors go on the right. Solder your wires in this order from left to right. White, blue, white, green, black, blue, black, green. If there are differing lengths of blue and green together, match those with the white and black lengths. After you solder your wires onto the diode, take a centimeter of your 1/16 inch heat shrink and put it over the solder connections. Heat it above the flame of a lighter until it is shrunken around the connection. Keep these diodes in their groups for later. After you complete a group of diodes, you can solder them to your optical board. You want to look at it in the way that is currently shown. On the left side from this view is where the blue pair of diodes go, and the right is where the green goes. Strip both wires in the blue LED and tin them. From your view, the bottom right pair of the pads is where they should go. The blue wire goes into the bottom and the white goes into the top. When the exposed wire is sticking through the bottom, put a dab of solder there to seal it. Follow the same pattern for the rest of the diodes, swapping white for black and blue for green. Once all the diodes have been soldered in, you need to test the optical board. Plug the board into the base connector with the black wire matching up to the pin labeled FB2. Then power your Dexter on and open DDE. Hover over the Jobs menu at the top and select Calibrate Dexter at the bottom. Then click on the button that says Start J1 and wait for Dexter to start moving. Once it starts, shine the green LED into the green phototransistor and move it around a bit. You should see the X-axis move, which means it is built correctly. Do the same thing for the blue pair, which corresponds to the Y-axis. Test each optical board to make sure they work. Afterwards, put some hot glue over the tops of the wires for strain relief. Get some on each side of the wires. Do not get any in the potentiometers. Repeat this for the rest of the boards except the rotate optical board. After your optical boards have been made, you're going to prepare your 3D printed mounts. Your base photo interrupter is going to take 3 number 19 nails. The pivot is going to take 2 of the provided satin pins. The top rotate piece takes 2 of them as well. When the nails are mostly pushed in, put a small drop of super glue at the top and push it all the way in. Now we're going to mount the photo interrupters starting with the base. To start, take an M3 nut, thread it on a bolt, and put some super glue around the outer edges of the nut. Then, push it all the way into the 2 hexagonal holes on the right side of the main pivot. Take the bolt out and repeat for the other nut. Take the other base photo mount and line it up with the nuts and the nail holes on the bottom. Then take 2 M3 by 8mm bolts and tighten them into the nuts. They're supposed to sink in. Then, take the base photo interrupter with the nails in it along with your base optical board. The photo transistors are going to go in the side with slits. This is the rule for all of our optical encoders. Stick the blue one into the left side and match up the flat side of the diode with the shape of the hole and push it down as much as possible. A small flathead screwdriver may help push it down all the way. Match up the blue and green diodes with each other. Fold both sets of LED wires down. Trim the ends of the nails off until you can push both pieces together flush. Then push the nails into the holes on the mount. For the J2, stick 2 number 19 nails through the pivot photo piece that the photo transistors go into on the side of the diode. Superglue the length of the nail and push them both down all the way. If the nails bend, just bend them back. Then push that piece into the other pivot photo piece with the lip facing inwards. Then stick your green photo transistor on the left side when looking at it. Match up the other sides. When you're putting the photo transistors on, bend the wires upwards toward the curved side. Bend the LEDs downwards. Then you're going to super glue your pivot code disc in a place where it is flush against the arm body. Be very careful not to glue the bearing. You're going to mount your pivot photo pieces onto the left side of the arm body when looking at it from the pivot. It should be flush against the curve. Then coat the bottom of the longer piece in super glue. Press it back in place and hold it there until it is dry. Then, coat the back of the optical board in hot glue to insulate the connections and mount it on the tube between the arm body and the external gear. Then, run your connector under the base connector and down the PCB spacers. Run it underneath the fan and down the belt directors without them touching directly. For the end arm, take the photo interrupter and look at it from the front. The blue side goes on the left while the green side goes on the right. Hot glue them in if they fit loosely. Feed both LEDs through the hole in the top and match them up with their photo transistors. Then slide them all the way down into their slots. A small flathead screwdriver may be needed here. Pull the rest of the wire from the LEDs out and push what's left over into the notch below the hole. Put some hot glue right there and hold the wires back while it dries. Then after it's dry, line the groove between the diode pairs up with the code disc. Give a firm press on top until it snaps on. Connect your end arm connector to the optical board. Glue the optical board down on the axis intersection. For the angle piece, the green goes on the left and the blue goes on the right. It mounts right below the diff body B. To mount it, line the two nubs up with the two holes. Then press it in with a lot of force. A channel wrench may be needed to get this amount of force. On the other side, there are two holes in the diff body A for the LEDs. Feed the LEDs over the first belt under the second one. Then take your angle connector wires and run them up the end arm hub. Solder a 6x connector onto the end once the wires have been fed through and put strain relief on it. The angle goes on top and the rotate goes on bottom. To begin your rotate, feed the LEDs and photo transistors through the shaft. Then take your hooked rotate photo piece and point the hook towards you. Your LEDs will go in this side. From this view, the green goes on the left. Make sure they're pushed in all the way. Once they're pushed in, push the wires to the right side from this view. Now you're going to put it on your differential. From the harmonic drive view, it should sit on the left side. The wires should stick out of the center at the bottom and you may need to cut the piece to get it around them. Then you're going to put two number 19 nails into the top piece from the holes for the diodes. Push them in most of the way and then put super glue on them. Then push them down the rest of the way. Trim the ends off and give it a couple minutes to dry. Match the diode pairs up. Slide it into the nail holes on the first rotate piece and sandwich the code disc in between them. Do the same thing you did before with the angle connector to connect it. Once all of the optical boards have been connected to Dexter, you can get the center points of what we call the eyes of each axis. Connect your Dexter to your Ethernet port and open DDE. The default static IP address of a new Dexter is 192.168.1.142. There's a page on the Dexter wiki on how to connect Dexter to your computer. After it's connected, go to the Jobs menu at the top and click Calibrate Dexter. A dialog box will pop up. Select the Dexter you're using from the top menu, then click Start J1. Once Dexter starts moving, a circle should start forming in the view window to the side. You want there to be a common point for each revolution, which will become the center. If the eye ends up closing off from the center, you need to readjust your optical encoder. If the circle is too small or too big, the potentiometers on each optical encoder control the X and Y axes. It's too big if a flat line is being made on either the top or the right sides of the window. Once the joint runs through all of its points, click somewhere in the open space, preferably in the center. In the output pane in DDE, 2 hexadecimal values will come up. Click Save and they will be written to your Dexter. Click the button at the bottom left that says Calibrate Optical Encoders and let Dexter run through its calibration. This should be done every time you power up Dexter. If you've done everything correctly, Dexter will go into keep position mode when it's done and should resist any force applied to its axes.